I'd like to introduce Josh Hoff, who's an experienced software developer here at Matovi, who's been in the industry for almost 10 years. He's done it all, front end, back end, DevOps, and more, with tons of different languages, frameworks, and tools. Today, he's going to continue his series on shell scripting and teach us how to catch bugs in your scripts before even running them. He'll cover a common linter, the anatomy of a script, and some commonly used tricks to help you write shell scripts more quickly and accurately.
There we go. The table of contents, I'm going to go over some shells you can use and the differences, the linter and some other high leverage tooling that can make your scripts easier to write, easier to debug, and some basics, and then a quick demo. So these are the most common shells. SH follows the POSIX standard, and that's going to be the most portable. You'll see it on like all systems, Alpine Linux, the Musil system, and BSD systems like FreeBSD. Otherwise, you'll usually see Bash that has some more features like arrays and stuff. You don't necessarily need those, but some things to be aware of. You'll need to install it on like BSDs or Alpine. And then if you use OS X, you'll be 2 major versions behind. So you'll want to install the one from Brew to get the same version that the Linux is going to use. So on to the tooling. I'm starting with the tooling because I think this is really important. I don't think a lot of people use linters, and they're actually super worthwhile, not just because they can point out errors and catch typos, and humans are just like really bad at repetitive tasks and machines are great at them, but because they can teach you things you didn't know. And to that end, the one I use for shell scripts is called shell check. I should have done that Sally sells seashells by the seashore before this. But anyway, it's great because it covers a lot of different cases. And then they also provide long form explanations on their wiki of what error you're getting and why it's there, alternatives on how to fix it, and then how you can ignore it if you know what you're doing is safe. So it's pretty easy to install. It's just a separate program that runs. And you can and should install an editor plugin. So I think the Vim and Emacs ones they cover a lot of different linters, but I'm sure there are also editor plugins for the other editors that cover more than one linter too. So that's all in the README. It's pretty easy to do, and it's totally worthwhile. Another tool that I haven't really used much, but I think is worthwhile, is a formatter. It's just for consistency, and it'll also point out errors if you forget like a semicolon or something. It'll indent things properly so you can figure out what you've done wrong. Go-to-fail was a popular bug where something should have been de-indented and the developer would have caught it if it was, but they indented it thinking it did something that it didn't, and it was a security flaw. So this is a really basic shell script. It's just a hello world. You'll see shell scripts start with a hashbang line or a shebang, it's called sometimes, and then one or more commands to run. And you'll specify like bin bash or bin sh there, depending on what script you want to use or which interpreter. Okay, so exit statuses are one of the most important things in shell scripts because they're used in like Boolean logic and flow control. They're totally separate from output, so you won't see them on the screen. So if a command returns successfully, it'll return 0, and then failure will be anything that's not 0. So like if you try to cat out a file that doesn't exist, if you try to print it to the screen, it'll give you an error and it won't show a number. But then if you echo this dollar question mark, it'll show what the status was, and that was 1 because I couldn't find the file. So where is that useful? For starters, it's useful in if statements. And you might notice that these don't have the square brackets, and we'll cover those next. But these just work like if statements in any other language, except for they're based on whether or not the command returned 0 or non-zero. So these square brackets, these are actually just another command on a lot of systems, the test command. So it's really handy if you do man test to look at the manual. You can see like you can compare strings, or you can compare integers with -gt. So you can see all of the things that this supports, and that's used a lot. You may have also seen a double square bracket, and that's used in Bash specifically. So shell check will let you know if you're using that and you've specified sh. That supports more stuff, I would assume, with arrays. But usually this is enough for me, so I haven't really used the double one too much. Loops are pretty simple. You kind of loop over things that are space delimited. So if you like get the output of a command and it lists a bunch of things separated by new lines or by spaces, then it'll just set this variable based on the output of the command. A more simple way to see that is like if you just have space separated strings, then you can loop over those. While statements work kind of like if statements. And if you were to do like man test, you can see that this just looks to see if the file exists. So these are pretty simple statements. You can like loop through and wait until the user enters something with the read command. And then and or. So this also uses exit statuses. So if you do like test, or if you use the square bracket, and then you can use these ampersands in here to decide when to do things. It's pretty simple, but just knowing that it's deals with exit statuses is very useful. And you can mix and match too. Like you could say, you know, if a file has something in it, or if this variable is greater than 2, then do all this stuff. And then this is just a quick one on output. There's lots of things you can do with output, but the basics are that there's standard output and standard error. And so standard error is what shows up when there's an error. But if you don't care about that, you can just redirect it all to dev null. Same thing with standard output. So both of these will do that. And then a quick summary, we went through different types of shells, just sh and batch. There's a lot more than that, but those are the two main ones. And then why you should use a linter and which one I recommend. Format your scripts, and some flow control stuff. So let's see a demo. So I have kind of a simple script here. The goal, let's make it bigger. Here we go. The goal is to rename lowercase files to uppercase names. It's contrived, but you can see kind of the stuff that we went through in this presentation at use. Sorry, cat wants attention. So if I run it right now, you'll see it asks for a directory. And then for the most part, it's probably going to work, but you'll see it's not printing out some variables. So let's use the linter I talked about to fix those. The first error it complains about is quoting things. This doesn't really affect anything here, but it can if you loop over stuff. The second one is that bug. So expressions don't expand in single quotes. And this is something we didn't go over. If you single quote things, it doesn't expand variables, but if you double quote them, it does. So that's good to know and caught by the linter. And then I just commented out the actual point of the script, which is to rename the file. So if we list out the files, then you'll see that they're kind of mixed case. And then if we run the script again, you'll see it rename them. Any questions on all of that or the example?
Josh, quick question. When you do that / to prepend a script, is that just a syntax convention? What does that mean when you do the?
So this just means like run the script from your current directory. So dot is your current directory. And when it's looking for, when your like terminal is looking for stuff to run, it'll look in your path variable. So if this isn't in your path, it's just a way to tell it like, hey, run this specific thing instead of like, you know, ls or something, which is somewhere else that's in the path variable.
Okay, cool.